This is one of the lab problems from section 2.6. It says here to find all the vertical and horizontal asymptotes for this graph, and here's our graph. Step 1, first determine the vertical asymptotes. Since f of x is a rational function, we can write it as a numerator of x times divided by the denominator of x, where n and d have no common factors. Because if they do have common factors, we can cancel them out. And the graph of f has vertical asymptotes when the denominator is equal to 0. This occurs when the denominator is equal to 0, f becomes very large in magnitude. Given this, what is the equation of the vertical asymptote? So the vertical asymptote would be obtained when we set this thing equal to 0. So if we set this equal to 0, we're going to get 1 plus 9x equal to 0. Maybe we can write that down here. We're going to get 1 plus 9x equal to 0. And then we're going to solve for that by saying bring the 1 over to the other side. We get 9x equal -1. And then we'll divide by 9 on both sides. So then we'll get x equals -1 over 9. So I think if we write the whole thing, we're going to get the actual equation. So x equals -1 divided by 9. And that is going to be our vertical asymptote. Now that we have that, determine the horizontal asymptotes. Rewrite the numerator and denominator so the powers of x are in descending order. And so we'll just switch the order so that -8. So let's make sure that -8x plus 1. So this slot here would have a constant -8. And then this would be a 9. So all we're doing is rewriting or switching the order. And this will allow us to figure out the degree. I mean, you could have figured out the degree, but they're taking really small steps here. So horizontal asymptotes are determined by comparing the degrees of the polynomial. If the degree of n is less than the degree of d, then y equals 0 is a horizontal asymptote. That's just the x-axis. If the degree of n equals to the degree of d, then a horizontal asymptote would be the two coefficients. The leading coefficient for the numerator divided by the leading coefficient for the denominators. And if the degree of n is greater, then the graph has no horizontal asymptote. It might have what's called an oblique asymptote, or it might end up following another different power function, but we won't worry too much about that. So the relationship between the degrees, the degree here is that they are both to the first power, so they're equal. And because now that they're equal, then the leading coefficients would make up our horizontal asymptote. So the horizontal asymptote is going to be, I don't know if they want the actual equation, but if we do the actual equation, it's going to be a y equals equation. So -8 divided by 9. And if that doesn't work, we'll take out the y equals, and then we'll get it to work. Well, it looks like it took it. So that's our function. It's always good to graph this right after. So let's take out our graphing tool. And then we're going to graph y equals, and then 1 minus 8x divided by, whoops, the divided by here is a little tricky. So let's put the 1 minus 8x up on top, and then the 1 plus 9x in the bottom. So this is very subtle. It's hard to see without it being zoomed in or zoomed out. But here is our horizontal asymptote. If we look at the y value, it's getting closer and closer to that. Hard to tell, but -8/9. And then if you look at the x value as we get closer and closer to the asymptote, again, hard to tell. Looks like it'll be negative 1/9. It's on the negative side because these numbers from the right side of the graph is on the negative side of the axis. But what we can do is actually graph those other equations. So we have x equals minus 1/9, and we have y equals minus 8/9. And so if we graph those other two graphs, you'll see that the original graph, the red graph, is approaching our horizontal asymptote, and if we follow the vertical asymptote, we're also approaching that vertical asymptote. Okay, so looks good, and I hope that helps.